Okay, shall I start? Oh, wait.
Yes, just we will wait just a couple of minutes. Let that.
Just let me know when to start talking.
Okay. We are good to start, Doctor.
Okay, thank you very much. Okay, hello everyone. Good afternoon and assalamu alaikum. Hope you all are well. And welcome to Abu Dhabi University online series of workshops for investing in our community. So today's workshop is related to building your own robot. So in this small workshop, I'm going to try to impart as much knowledge as I can related to building your own robot, so that you get enough information related to the different applications that this current field of robotics and artificial intelligence offers to us. Different examples we'll have a look at, and what type of robots are there, and then I will work towards a small simulator program. So basically this tutorial is aimed at anybody who is willing to get started in robotics and have a basic understanding of terms like, what are motors, what are sensors and actuators. Now, the agenda, for this workshop, or the outline, is that I'm going to introduce robotics to you guys. Then we'll talk about some of the basic steps to building our own robot and designing a robot using a simulator. So in the end, I'll show you a simulator on which a simple robot can be designed, and then the program can be loaded into an Arduino microcontroller and make it work. Now, deployment of robotics and artificial intelligence and machine learning based systems, it can bring a lot of performance benefits for organizations. Robotics and artificial intelligence will improve product and service quality. It will increase throughput. It will enhance employee safety for a lot of applications. It will increase, most of all, customer satisfaction. Now, it is incorrect to regard robotics and factories of the future as a new concept, because it's not. They have existed for decades. It is the perspective around them which has actually changed, or which has evolved, we can say. When a guy named Henry Ford, he replaced horse carriages with automotive engine, robotics became the driving force of our lives. Now, if we talk about artificial intelligence is when a system can complete a set of tasks or learn from data in a way that it seems intelligent or smart. Now, those devices can analyze data, they can make decisions and act on that data without the involvement of humans. For example, smart retail, it looks at consumer behavior, then it looks at marketing strategies, then where to place product placement decisions are taken. So this is all smart retail. Drone traffic monitoring, then adjustment to speed limits and timing of traffic lights without human involvement. So a lot of applications related to adaptive traffic light monitoring, that involves artificial intelligence. Office building lighting, temperature maintenance, attendance, how it's taken through computer vision. So all of these applications involve artificial intelligence. It's the combination of robotics and artificial intelligence which is actually causing a stir and is, causing so many developments in different fields. Now, what is a robot actually? So, if any sufficiently advanced technology is indistinguishable from magic, this is what Arthur Clarke said. He said, any sufficiently advanced technology, it looks like magic. So to a novice, all science is actually indistinguishable from magic. Now you try to show a magnet to a 4-year-old, a very excited 4-year-old, and it'll seem like magic to him, So it's the science behind it, which separates it from magic actually. So basically robotics is pure science, but a little bit of magic. It's an electromechanical device which can react to its environment and take autonomous decisions for any kind of application. It takes actions in order to achieve a specific task, right? So it's a device, it's an electromechanical device that has electronics in it, there are mechanical parts in it, it is sensing its environment, and based on that, it is reacting in a specific manner. It is taking some decisions, it is performing some actions, it is performing a specified task. Now that is our robot basically. Now, if we talk about the impacts of robotics in everyday life, now you might think that no, it's a thing of the future, but no, it's now being added into our daily lives in so many applications, like self-driving robot. In factories, a lot of applications are there, and already robotics are playing a lot of huge part. Security and defense and surveillance, and I'll talk about this in a bit more detail with every application. Manufacturing, health and medicine, education, food and beverages sector, domestic help. So yeah, they're there. One by one, I will talk about them as well. Now, for example, automated transportation, security, defense, and surveillance. Now, in modern world, buses, trams, trains, they are all automated. But vehicles like cars that run in the street, they're not quite general. But obviously, smart cars or self-driving cars now are beginning to emerge. Audi, Mercedes, Google, they're all introducing self-driving cars in addition to Tesla. Some robots now are relieving humans by replacing them from dangerous jobs, like robotic welding to avoid obviously intense heat and noise, inspection of pipelines that could be full of toxic gases, to arm and disarm bombs. Robots are being used. Now robots are also being used as a nuclear weapon cleaner, nuclear waste cleaner. Sorry. As firefighters, robots are being used. In extremely high temperature, environments. But now robots are sent to, assess the environment. They are also being used as a sewer scraper. Now, recently, engineers have successfully discovered or, built surgical robots. Now, this success has obviously attracted large financial investments on robots in medical science. Now, robots are also being used in service industry and education, especially now with distance learning. It is for that also robotics, robotic applications now, are coming into play. For some hotels, they have also now started using robots to provide food to the customers. Also, specifically in education with respect to autistic children, who generally, they find it irritating and confusing when they communicate with other people. So a humanoid robot, which looks like a person, a human, it is very easy for such children to interact with such a robot, and a lot of research has gone into it, and it has shown very positive results, in experimentation with these children. These robots help autistic students by teaching them social cues, educational lessons, obviously. Now, there are 3 trends to actually watch in AI and robotics. The combination of artificial intelligence, as I said, and industrial or collaborative robotics, it has the potential to change the world. AI unlocks entirely new capabilities for robots, which without AI are rigid and unresponsive to the world around them. So robots are like machines, but when you incorporate intelligence into them, artificial intelligence into them, that opens up a lot of doors for very smart applications. Now, Internet of Robotic Things, IoRT, this is also an emerging paradigm that brings together autonomous robotic systems with the Internet of Things vision of connected sensors and smart objects pervasively embedded in everyday environment. Now, when things such as wearable devices, refrigerators, digital assistant sensors, and other equipments are connected to the internet, it can be recognizable by other devices and collect and process data. So you have the Internet of Things. So this is Internet of Things, right? So you're combining basically robots with Internet of Things. So robot training is the first thing. Robots like Baxter and Sawyer from Rethink Robotics can be trained by simply guiding their arms a few times. So it learns through demonstration and programs that correct motion itself. 3D vision. Even the simplest tasks a robot performs will depend on 3D machine vision. Now, 3D machine vision, it detects objects regardless of its position. As a result, robots have more flexibility and independence when you compare them to its 2D, 2D only counterparts. Because obviously, the vision of robots, it is acquired through computer vision, through camera lens, right? That's a 2D, vision. Now, robot vision with 3D lets the machine know if an object is, lying down, it's upright, it's hanging, there is a defect. 3D imaging is currently being used in metrology, guidance, and defect analysis systems. Now, there's a term which is used, stereo vision. Now, in stereo vision, what happens is that 3D information on a part is obtained by observing a common feature from two distinct viewpoints. Now, this distance is calculated for each viewpoint. It returns XYZ values. Now, if you have multiple features are located on the same part, then 3D orientation can be calculated. Now, I don't want to confuse you, but 3D vision is something which is a very emerging field now. Now, the next thing is cloud robotics. Now, cloud robotics is an emerging field of robotics rooted in cloud computing, cloud storage, and other internet technologies centered around the benefits of converging infrastructure and shared services. This allows robots to benefit from the powerful computational, storage, and communication resources of modern data centers. Okay, so this has to do with your cloud robotics. Now, so this was all the introduction part being done for the robotics. Now, if you talk about, what is required, what are the different components which are required when you want to build a robot? So what do you need to consider? We need to think about the platform. What kind of robot are we building? Is it a land robot, an aquatic robot, or a flying robot? Then what kind of sensors are they going to be? What sensing capability that robot would have? What kind of actuators would it have? How would it impact on the environment around it? The microcontrollers that will be used? What type of motors would there be? How would you assemble the robot? And how would you program the robot? So these are the basic things that you consider while, when you're thinking about making a robot. Now, first thing, the robotic platforms. Now, what kind of platforms are there? As I said, they could be a land robot, water, and an air. So land robots are three types of robots: wheeled, tracked, and legged. Water robots, these could be like aquatic boats, swimming robot, and submarine type robots. And for air, it could be like aerial planes, blimp, and helicopter robots. Now, these are the three types of your land robots. As you can see, these are the legged ones. There are tracked, and then there are tired ones. Now, when you talk about the legged ones, it can potentially overcome, large obstacles because it will, hop over like a spider over different obstacles, and it can navigate through rough terrain. However, it requires increased mechanical, electronic, and coding complexity, higher cost to build, obviously, as well. So these are the downsides. Now, when we talk about tracked robots, it has a reduced slip because it's more contact area. It evenly distributes its weight. It is perfect for sand and gravel kind of material. It looks obviously quite aggressive. However, it can damage surfaces while turning and causing wear of tracks. And it has increased mechanical complexity. Now, obviously, it totally depends upon your application requirements, for what kind of terrain are you building your robot for. The wheeled one is the most popular type of robot. For beginners, it's low cost as well. It's easier to manufacture. There are so many choices for wheeled robots. Simple design and construction. However, it has a tendency to slip when it goes a little faster, especially on wooden surface or a marble surface or this kind of thing. It can lose traction. It has small contact area. Now, the aerial robots, we know about autonomous unmanned aerial vehicles, UAVs. They're excellent for surveillance. The advantages of building an autonomous UAV, especially if you're a beginner, the advantages have yet to outweigh the risks because there are more risks involved for a beginner. So whenever you're considering an aerial vehicle, most hobbyists will still use commercial, robots that are available, remote controlled kind of aircraft or drones. But obviously, these applications have been used specifically for military purposes as Predator, aircraft or drones. Now, remote controlled aircrafts have been in existence for decades. We know that there is a large community for the mechanical part. However, there is limited robotic community to help you with the autonomous control. So I mean, if you want to control it manually, that's been there for decades. But for autonomous control, that's where the field is emerging still, and you would find limited robotic community or help on that particular aspect. Another disadvantage, obviously, with aerial robots is that your entire investment can be lost in just one crash. So everything is gone. Now, if I talk about aquatic robots, increasing number of hobbyists, companies, institutions, research companies, they are developing unmanned aquatic underwater vehicles. There is, companies have also launched pool cleaning robots, for example. Underwater vehicles, they can use thrusters, tail and fins, or even wings to submerge. Advantages is obviously most of our planet is water, and there are a lot of applications obviously for monitoring aquatic life or the quality of our oceans. So yeah, there's a lot to explore and discover. So a lot of potential is there, especially if you can design an autonomous kind of an aquatic robot. Design is obviously guaranteed to be unique. It can be used or tested in a pool. However, the disadvantage is that robot can be lost in many ways. Obviously, it can drown, it can sink, there could be a leakage, it can entangle into weeds or something, and you wouldn't have any way of retrieving it. Another complex part is that most of the electronic parts, they do not like water. So a lot of effort would go into making it waterproof, or that water doesn't go into the electronics. So this is what you're going to have to think about. Also, surpassing depths of 10 meters or more can require significant research and investment. Again, limited research communities there to help. Limited wireless communication options are there, especially for if the robot is intended to go into more depths. Now, robot sensors. Now, emulating a living creature's senses it's impossible. It's very difficult. So researchers and developers have resorted to alternatives to biological sensors. Obviously, human sensors, you cannot replicate them into a robot. Now, how you can compensate for that? Robots use a variety of different electromechanical sensors to explore and understand their environment and themselves. Why do robots need sensors? These kind of sensors, because different application requirements, actually, it depends on that. Now, if we talk about that your robot should be able to see, how is it going to see? Using a camera, right? A robot may be able to pick up an image made up of millions of pixels, but without programming, it would not know what those pixels mean, actually. Distance sensors would indicate the distance of an object, but it would not stop the robot from bumping into it. So you need to program it to how to avoid obstacles or how to, avoid bumping into somebody else. Now, if you talk about taste, robots have a really hard time tasting and smelling. Obviously, as a human being, we can tell if something is sweet, something is bitter, but obviously that a robot cannot do. However, a robot can do something else. It can tell you the chemical composition of that particular food item. So, so it's something else that you can achieve through a robot. And as far as smell is concerned, there hasn't been much demand for a robot that can actually taste or smell. So a lot of effort hasn't really gone into developing sensors for that. Now, as far as the touch is concerned, humans have nerve endings, throughout their skin. And as such, we know when we have touched an object, we know whether it's hot, it's cold. Now, robots are equipped with buttons or simple contact places in strategic locations. If it has come in to determine if it has come in contact with some object. So now you have to obviously very, strategically decide where to place, those buttons and those pressure sensors, for example, to determine a touch or a contact. So for example, in a robot pet, they may have a contact or a force sensor placed on their head, feet, or back. Now, so if you try to touch an area where there is no sensor, obviously robot has no way of knowing that they have been touched or they need to react, So you need to obviously think about it in that particular manner. Now, robot senses that humans cannot. That's what I'm trying to say. There's no need to actually try to make a robot, compete with the human senses. You can equip your robot with different senses. So a robot can detect pollution. It can detect chemical composition of a substance. It can measure exact distances, which a human cannot. It can do thermal imaging for detection, So a robot cannot tell you if a substance tastes good or if there is an odor, something smells bad. However, it can give you more information that a normal human being can. It can give you, for example, a robot equipped with a carbon monoxide sensor would be able to detect the gas levels, which is actually colorless and odorless for humans. A robot can also tell you the levels of pH, in the environment. pH level of a substance to determine if it is acidic or it's basic, which obviously we as humans through our, eyes, we cannot do that. Humans use pair of eyes to get a very good sense of depth, though for many, accurately gauging distance is not easy. Now, robots obviously through its position sensors, through motion detection and ultrasonic sensors, infrared, all these kind of sensors, it can give you exact distances of obstacles. Now, a human can tell you based on experience if they think that an object is cold or hot. However, a robot through thermal imaging, 2D thermal imaging, it can tell you or describe to you if an object is, hot or not. So to make us feel better, we can say that humans have 5 senses, but robots can have, an infinite number of different sensors or different senses. So although I would say there's no comparison, of intelligence of a human being with a robot, but that's a different debate, So now, the different types of sensors, these are the different, possibilities that you can equip your robot with. position sensors, rain detection, IR sensor, again, touch sensor, humidity sensor, a gyroscope, IR, gas sensors, color sensor, proximity, ultrasonic, soil moisture. There are obviously chemical sensors as well, which are not listed here, but there's a huge list of, and so much research is going into developing, more and more sensors for harsh environments, so that you can send robots into severe environments which have very high temperatures, or high gas levels and stuff, but your robot can still survive and do its job. Okay. Now, just a little briefly about the different kind of sensors that are there. Distance measuring sensors are there, infrared, ultrasonic, laser. Obviously, they all provide you different kind of ranges, and the costs are different. Infrared is low cost, reliable, and accurate. Closer range than ultrasonic. Ultrasonic is medium range. It is affected by surfaces. Laser is more high accuracy, and it can measure distance at a longer range as well, but it's much costlier. Environment sensors, there's no limit of so many environmental sensors: humidity, pressure, different kind of gases, thermal, sound, light. Okay, excuse me. Rotational measuring sensors, you have potentiometer, gyroscope, positioning sensors, for indoor localization. GPS is also used. Now, apart from sensors is through which your robot senses its environment, perceives its environment, feels its environment, receives input from the environment. Actuator is how it reacts to the environment, how it performs actions towards the environment based on obviously a specific input. So actuators, there are different kinds of motors actually through which actuation is performed or actions are performed. These motors range from DC motors to servo motors to stepper motors. And obviously then again, there are different ranges within them. Now, DC motors or gear motors are the ideal choice for robots with wheels or tracks, as they provide continuous motion or rotation. As far as if you want a specific angle movement, like in the arm being shown in the picture, that movement you can achieve through a servo motor, which moves at a specific angle, 90 degree, 180 degree, or something else. As far as the stepper motors are concerned, if you want your robot to move to a specific distance or take certain number of steps and then come back, or maybe move forward or backward, then stepper motors are very ideal for that. Now, if you talk about the microcontrollers, that is the heart of actually a robot. Obviously, there is again a range of microcontroller boards that you can use, starting from very simple ones to very advanced ones, depending upon your application requirements. A very simple robot you can make through your Arduino board. Then, if you want to incorporate computer vision into that, you can move ahead to Raspberry Pi. And then further on, you can, think about turtle bots or just Jetsons or, Xavier. These kind of robots are there, or, brain of robots you can build with these kind of microcontrollers. Sometimes you use multiple type of microcontroller boards to achieve different tasks. Maybe one, processing engine would be for controlling the movement of a robot, and another processing engine would be acting as a brain of the robot, maybe detecting the environment through computer vision and running those applications. So it depends. Now, microcontroller, obviously, we know what they are. It's a computing device, basically. It is capable of executing any specific program that you put into it, a sequence of instructions, basically. So in a robot, obviously, it acts like a brain. It would contain a processing engine, a processor, basically, central processing unit, memory would be there, IO devices, so that's what your microcontroller is. Okay, so Arduino Uno is a very simple, for beginners, because this workshop is mainly intended for beginner students in robotics field. So Arduino is something to start with immediately. You can do it. It's very easy programming. It's a microcontroller board based on the Atmega 328 microcontroller. It has 14 digital I/O pins, of which 6 can be used as PWM or pulse width modulation outputs, like as an analog output. 6 analog inputs are there. 16 megahertz ceramic resonator is there. USB connection is there. You can attach a Bluetooth device with it. So it's a very simple and very popular microcontroller board for beginners. Okay, now I'm gonna talk about the design of an obstacle avoidance robot. Now, an obstacle avoiding robot is a type of autonomous mobile robot that avoids collision with unexpected obstacles. It's a very simple robot that you can build either with only a single ultrasonic sensor, or you can have ultrasonic sensors all around it to detect obstacles from all the sides. Now, the robot design that we're going to be talking about, it will use 2 motors. Microcontroller will need, 2 digital pins for direction control and 2 PWM pins for speed control. Speed is controlled, for a motor using analog output. Although Arduino doesn't have an analog output, so we use actually PWM pins for that. Okay, I wouldn't go into too much detail of that. Now, if we talk about how to select a microcontroller for a robot, again, it depends upon the features. And as I discussed earlier, that it depends upon your, application requirements. If you want to more high processing kind of an engine, then you will go, further up, according to your. Now I am gonna play this and hopefully you can hear it. Okay, just. Okay, so as you can see, it was a small video for showing you obstacle avoidance robot. It's a very simple, very basic model that was developed, with a simple program. And as you can see, ultrasonic is good, for detecting for a medium range, but it was built with a single ultrasonic sensor. What happens is that it cannot detect from the side if there is some obstacle on the right side or on the left side. It can detect obstacle in the front. If you want a very good, precise, accurate, obstacle avoidance, in a robot, then you're going to maybe use multiple ultrasonic sensors, or you could incorporate some other type of, distance measuring or detection sensor as well, like an IR sensor. Now these are the design elements. Now I'm going to be showing you an FSM for a obstacle avoidance robot, but that will use 2 motors, and I will be using 4 ultrasonics for that. And I will show you its simulated version as well. Now, these are some of the components that you might need. Okay, so Arduino Uno microcontroller is needed, ultrasonic sensors, your motor driver, your motors, DC motors, 2 motors are required. Now we use 2 DC motors to design this kind of a robot. Now, how you actually, control the movement is that when both the motors are made to go forward, in one direction, that is forward. Both motors going backwards, or in the reverse direction, that is backwards. Now, in order to go left, what happens is the right motor goes backwards and the left motor goes forward. So basically what happens is this motor will go backward and it will, actually rotate the robot towards back position, and this left motor will try to move forward. So this is how the direction is changed, and your robot starts to move on the right direction. And similarly, if you want your robot to move in the left direction, then the left motor will move backwards and the right motor will move forward. So actually, this is how you control, just only using two motors, you will control all of these four movements. Now, these are the different tools that you need. Tinkercad is a simulator, very simple simulator, free of cost, online available. Just have to create an account and you can start programming into it. Latino, in which you can make your FSM diagram, your state diagram, on how you want your system to work. Arduino is your, the microcontroller board that you would have. Now, this is the basic FSM, the finite state machine chart for your robot, obstacle avoidance robot FSM. You have the initial state, which is your idle state, in which no motors are moving. Okay, it's all zero. Now, as far as this is your forward state, in the forward state, as you can see, 0, 1, 0, 1 is actually both the motors being set to go forward. The backward direction is here, which is the opposite of that, 1, 0, 1, 0. So this is your backward motion. Now, how this actually works is, it obviously depends upon your algorithm, how you want to design it. But what we have done is that robot will always move forward unless an obstacle is there. Okay, it will always move forward. So that's why from idle, you first go to forward, as you can see in the diagram. Now, when the obstacle is in front of the robot, because it's going forward, as I said. Now, as soon as the obstacle comes in front of the robot, it will turn right by default. Okay, but obviously before that, it will check whether there's an obstacle in the right as well or not. Okay, so this is what's being shown here in this condition, as you can check. Okay. Yeah, so you can check in this condition. So if the forward distance is less than 100, okay, meaning there's an obstacle in the front of the robot less than 100 centimeters, then what will happen? It will start to go to the right, but before that it will check whether there is no obstacle in the right. So it is checking whether the distance which is calculated by the right ultrasonic sensor is greater than 100 or not. Okay, and then it will start to go right. Now, once it will go to right, then if an obstacle is found on the left, the robot will continue moving to the right. Okay. All right. So robot will turn to right, then left. If no obstacle, then go back forward. Okay. So it will go forward regardless. When there is an obstacle in the front of the robot will turn right. Okay. After right, it will turn immediately. It will try to turn left. Okay. It will go right and then it will try to turn left if there's no obstacle, and then again it will go back to the forward position. So basically it'll like rotate and then come back and then start moving to the forward direction. When the robot has an obstacle in the front, on the right, and on the left, I mean it cannot go in either of these directions, then it will go backwards. So this is sort of this FSM is. Obviously it depends upon how you want to design your particular obstacle avoidance robot. Now this is because the basic component that is being used in obstacle avoidance is ultrasonic sensor. So it's important to sort of explain to you as well that what is the mechanism of this ultrasonic sensor. What this ultrasonic sensor does is that it actually, it emits ultrasonic waves, sound waves, and those sound waves hit an obstacle and return back. And the distance is actually measured. Okay. How much distance that is, okay, by this, the simple S is equals to VT formula. We know the speed of sound, the time is actually returned by this mechanism, and you calculate the distance. Okay, so velocity is there, time is there, you find out the distance. And obviously that distance is divided by 2 because you're thinking about distance going forward, to the obstacle and then coming back. So actually, this is what is being shown here. There are 2, signals on the ultrasonic sensors, trigger and echo. So the signal is generated from the trigger, right? It goes, there's a pulse that is actually generated for 10 microseconds on the trigger line of the ultrasonic sensor component. As a result, what happens? A sonic burst is, generated, this 8-cycle sonic burst. Okay, and then obviously when it is generated, then the time is calculated from the generation to when that sound reflects back and is received back, like an echo is received back. So that time is obviously used in the equation or in the formula to find out the distance actually, that how much, and then you decide, okay, if you want distance to be 100 centimeters or, whatever in your particular algorithm. Now, this is the sort of the circuit diagram. As you can see in this particular diagram, only one ultrasonic sensor is being shown. And there is this servo motor is being shown. And there are 2 DC motors being shown. And this is the motor driver circuitry. And you have this Arduino. Okay. So basically, this is the design of the complete design of the obstacle avoidance with 2 motors, 2 DC motors, and you have 4 ultrasonic sensors on all the 4 sides. Okay, now I want to show you the coding for this actually. I don't wish to go into too much detail of the coding. Okay, because I don't know what the, whether most of you would be able to follow it or not. But, this is all the definitions actually for the 4 sensors, the trigger, the echo, the motors, signals you define, what kind of pins, what pins are there. So now this is all configuration for different pins, to which pin your motor is attached, to which pin your ultrasonic, is attached. This is the main loop and different states, that I showed you in the FSM that are being implemented. So in every state, you are actually setting up the direction of the motor actually, because if you recall, this is what we did in the FSM. In whichever state you are in, the motor is actually, both the motors are set to go in a particular direction. As I showed you in the forward direction, both the DC motors will be going in the forward direction. Okay. Whereas in the backward direction, both the motors will be going in the reverse direction. And similarly, right and left, I told you how it's made. So if you have a look, this is what is being shown here. In the idle direction, as you can see, both the motors 0, 0, 0, meaning it's stop idle, none of the motors are running. In the forward direction, as you can see, 0, 1, 0, 1. This is the pattern I told you, right? For these are two pins for the motor, right? 2 polarities for the motor. So you give a particular polarity 0, 1. Okay, so the motor runs in one direction. When you change the polarity, motor runs in the reverse direction. So this is the concept being implemented. Now, these are the values which will be returned by the 4 ultrasonic sensors all around the robot. And then you will check what is the value that is being returned by. Now, again, that particular logic will be implemented that I told you in the FSM, that by default, it will always go in the forward direction. If obstacle in the front, it will go in the right direction, then in the left direction, so on and so forth. So this is the logic which is being implemented here. And once you have the calculate distance is actually where the trigger is generated. That's a function that I'm going to show you here. So this is the calculate function, distance function, in which what happens on the ultrasonic trigger line, you generate a signal, as I said, and first it's a low and then it's a high for 10 microseconds, as I told you. But it's a delay for microseconds. So you create a pulse. You generate a pulse for 10 microseconds, and then you wait on the echo. So this is where you receive pulse in, echo, high. So you wait through this function, and you wait when will a high be received on the echo line. Okay, that's where the reflected signal comes. So that pulse in will give you the time duration of when the signal was generated and when it was received back on the echo line. Signal generated on trigger and the sound received on the echo. Okay, you calculate that distance, and then you put into the formula, of S is equals to VT, as I mentioned, and you find out the distance. And you see here divided by 2, because as I said, this distance is obviously between two objects like that. However, this distance is actually for the sound to leave the ultrasonic sensor and then hit the object and come back. So it's twice, right? It's giving us twice. So that's why we need to divide it by 2. So this is actually the program. Now I'm gonna show you actually this. I'm gonna run it. Just a second.
Backward, right and left, and 2 motors. Is supposed to move forward until the distance is less than 100, which means an obstacle is in front. The robot is then supposed to move to the right, left, and then continue forward if no obstacles are in front or on either sides. Now let me start simulation. The robot is moving forward since the distance is more than 100. Now, if the distance is less than 100, an obstacle is there, the robot will move right, left, and then forward when there's no obstacle. So the distance is more than 100, the robot will move forward. Now, if the robot is moving forward and then an obstacle is in front, on the right and on the left, the robot will go backward. So if the distances on all the sides are less than 100, then now the robot is supposed to move backward, and it's moving backward as expected. Now the robot, after moving backward, the robot will move to the right or to the left when the obstacle is removed and then continue to go forward. So the distance is more than 100 now on the left. The robot will move to the left and then will move forward when the distance is more than 100.
So I hope it was a useful workshop for you. This ends our session. This is what was about. I showed you the running version of our presentation of our project as well, and this sort of ends our workshop. I hope if there are any questions, please let me know. So if I just try to sum it up, I talked about the different applications of robots, and I talked about, the different requirements, for developing a robot. What are the different, system components that you need for developing a robot? I talked about in detail, about different types of sensors, different type of actuators. And also later on, then I, very in a simple way, I showed you how you can design your own robot using an Arduino, a simple FSM, and a simple code. So yeah, that's about it. I hope it gave you some basic knowledge about robotics and the different possibilities that are there for developing robotics applications. Thank you, Alla. Yes. Yes, we would definitely try to arrange more sessions on robotics. Any question? Can I repeat all slides to sum up? Okay, well, there was, if I show it to you, there were a lot of slides actually, 50 slides. So as you can see here, introduction, I talked about steps to building on robot and a small, example. I talked about the introduction, what are the different applications of robots, as you can see, what are the different trends to look for, what are the different kinds of, platforms that are there. So basically what to consider when building a robot. Different types of robots, your land robots, different types of land, legged, tracked, wheeled, aerial robots, aquatic robots, different types of sensors I talked about, again, types of sensors, actuators that you need. So basically these are the components that you need for developing a robot, what microcontroller to consider. And then, I briefly talked about this obstacle avoidance robot, how to build it. This is a simple one with one ultrasonic sensor. Then I talked about the tools that you require for building a simple robot, a simple FSM, a little bit about ultrasonic sensor, hardware diagram. I showed you the code as well. And then I showed you this video for, how you can, simulate it in a software. Once you have this program, then you can download this program into an actual Arduino, and then you can run it. Your robot would be ready to perform. Okay, most welcome. I hope you enjoyed this session. So that's it from my side. All the best for other sessions, and I hope you have been enjoying this series of lectures by Abu Dhabi University. Thank you.
Thank you, Doctor.
Thank you.